Okay, so for 12-3 inscribed angles, we're going to refresh our memory. So I said recall here. This is just refreshing our memory on something we learned in 11-1, okay? And that arc measure is based off the central angle. Remember where the vertex, the pointy part, is on the center. That is very important so that way you don't get confused with what we're learning about today about inscribed angles, okay? The vertex on the center is a central angle, and the central angle is the exact same as the arc measure, right? So now with inscribed angles, that's our new concept. It's an angle whose vertex is on the edge of the circle, okay? So I drew an inscribed angle right here because this picture can be a little confusing. So it's a vertex on the edge of the circle. So it's still inside the circle, but the butt of the angle, the pointy part, is sitting on the edge. Notice that that's very different than sitting on the center. I even drew the center on here. Now, what we do know about inscribed angles is that the measure is half of the intercepted arc. So the intercepted arc, if we take the arms of the chord and we extend them, that's the intercepted arc right there, okay? It's very important. We look at where the arms of the arc intercept the circle. So that's the intercepted arc. Well, if that's 100, I cut that in half, and that's 50, okay? Now, that works here as well. I have an intercepted arc of 100, and so my inscribed angle is 50 degrees. So we can see that right here. But I also have another one, angle D, ADC. It has the exact same intercepted arc of 100. So it's the exact same. It's still 50 degrees, which is very important. So that shows us when the shapes have, or when two angles have the exact same intercepted arc, it's going to be the same measure, okay? So one other thing I want to note is that an inscribed angle where the intercepted arc is a semicircle, so maybe there's a line here showing that it's a diameter, the vertex is still on the edge of the circle, so it's still an inscribed angle, but the intercepted arc is a semicircle. Well, we know semicircles equal 180, so this angle is always going to be 90 because half of 180 is 90. That's a very key concept. There's one more key concept I want to touch on real quick, and that's this last one. Opposite angles of a quadrilateral inscribed in a circle are supplementary. So what that shows us is angle B and angle D. You see how the intercepted arc of angle B is arc AC, and the intersected arc of angle D is ABC. In all, that makes a circle, 360. So that makes sense that B and D, when added together, would equal 180, which is half of 360. And then A and C would equal 180. And together, all four of them would equal 360. So that's just a fun, nice trick. I didn't put it in the notes because it can be a little bit confusing. But if you do understand how to use that properly, it can save you a ton of trouble. So that right there, maybe pause, look at that, because that's a key feature of what we're talking about today. Let me show you guys some example problems, okay? Let's turn the page. Oh, and one last thing. So sorry, I almost forgot. If we also have an angle formed by a tangent, okay? So the vertex of this angle is still on the edge of the circle. It just goes off outside the circle for the other part. So the intercepted arc is really this whole arc BDC right here. It's still just one half of the arc, okay? Nothing new is happening right here. It is half of this arc. Same with BDC or BC right here. It's half of the arc, okay? So we're treating it the same way as an inscribed angle. Its vertex is still on the circle, on the edge of the circle. So we still follow that rule. So keep that in mind. Even if the angle looks like it's coming off the circle, that's okay. That's a tangent line. Remember, tangents are only perpendicular to a radius or diameter, okay? So the problems are going to be a little bit jumbled up in here. Let me zoom in and focus. So right there, looks like a lot going on, but we can tell a lot of things from this. First of all, this is not a diameter because it does not go through the center, but I know that this angle is 60 right here. So that tells me, if I look at the arms of that angle, that that's arc A. So if the inscribed angle is 60, the intercepted arc must be 120 degrees, because 60 times 2. Okay, now if I know that's 120 degrees, I can figure out some other things, like angle B. If I have 120 and 30, so I'll add the 120 plus the 30, I get 150, and then B is formed by that, so I can do 150 divided by 2, and I get 75 right there. So you may have to look for other things in order to solve the problem. If this is just asking for B, you actually have to find A first. So maybe don't try looking for exactly what it's asking for, looking for anything you can find. Let's show you some more. Down here, I have that this is 40, okay? So I can see right here that this inscribed angle is going to be 20 degrees, right? I also can see that this arc is 70. So this inscribed angle is going to be 35 degrees. So that's just handy information. Now this is asking about angle 1, but we can see right here this is a diameter. Well, we know half a circle is 180, so half of 180, that's a right angle right there. Okay, but being able to identify those different parts are very important, okay? Let's look for angle 2. Well, first of all, I have 38 degrees right here, so I know that this is going to be 2 times 38, right? Well, angle 2 has the same intercepted arc as that. So that tells me that angle 2 is going to be the exact same as 38. That both of those angles are going to be the same because they have the same intercepted arc. The 70 here, we really don't need, okay? It doesn't really tell us any extra information. So that's something to keep in mind. We don't know where the center is here, so we don't know if this is a diameter. So don't just assume it is. But with the center there, we can. And last but not least is if we have a tangent line. These work the exact same way. It says that the measure of arc PMQ is 212 degrees. So this is the intercepted arc of angle SQP. So I can do 212 divided by 2, and I get 106, right? But really, it's asking for PQR. Well, I have a few different ways of doing this. I could know that this line is 180, so I could do 180 minus 106 to get 74. Or I could know that the whole circle is 360, and I could do 360 minus 212 to get what this is. I guess it'd be 148. And then I could divide that by 2 to get 74. So there's multiple correct ways to go about doing this. The most important part is that you are understanding that an angle with the vertex on the edge of the circle is always going to be half of the arc, okay? So that is what 12-3 inscribed angles is all about.